In previous lecture, we have seen that we will simple for cross validations. We have dividing our data sets in three partitions. Okay, randomly we have divided our data sets in three partitions. First part is called the train data. Second portions is called the second partitions of our data sets is called the cross validation data, and the third partitions is called the test data. We have seen this thing in previous lectures, and as typically we have doing this job at 60% of our whole data as training data, 20% of our whole data as cross validation data, and 20% of our whole data as test data. We have doing this job in previous lectures, and our data sets is look like this pair xi and yi. On this pair we have look our data sets is look like this pair, and xi is called the corresponding features vector and corresponding output is called the yi. If we take the binary classifier, their yi value is either 0 or 1. In generally we have taken the 0 for negative classes and we have taken our 1 for positive classes. Just previous lecture, in previous lecture we have seen these kind of things. Okay, so the main thing is that how to visualize these partitions of the data sets, how to visualize these kinds of. Suppose let's take we have the data sets. Suppose let's take I am using the blue color here for positive set of data points. Suppose let's take this blue point is the positive data point in from the D train. In D train, and I am using the red color here for negative data point in D train. In D train. Okay, and similarly I am using the blue circle here, blue close circle, and the same color, but it's surrounded by circle. It's is a positive data points from our cross validation data set. From our cross validation, it is a positive data point in the cross validation, and same thing in negative color we have taken here. We will take it is a negative data point in cross validation. Just to take this thing. Now let's see first draw some positive data points from D train. Suppose let's take our positive data points from D train is like that. Like that we have taken our positive data points, and similarly our negative data points from D train is like also like that. Like that. This is the simple negative data points from our D train. Simple, this thing is from our D train. D train. Okay, and and also suppose let's take we have the data points that's taken here in the circle. So let's take we have taken some data points from D cross validations like that. Here some points, also we have some points here, here, this kind of points are from our cross validation. Now why we are doing these jobs now, just patience with me, just bear with me. I will discuss everything step by step. Now first see the pictures. Suppose this is our cross validation point, and from positive set of data, positive data points from the cross validation partitions, and using the same data points from our cross validation, that is our negative data point from cross validation partition. Let okay, and have take some outliers. Suppose let's take we have some outliers. Suppose here we have some outliers from cross validations. Here also we have some cross validations outlier from here. This is a noise point, or simply you can call outlier point. Here is one's outlier point, and okay, this is simple outlier point. So these portions, these negative portions are called the positive points from D train, and these portions, these total portions, just I am using here another color to identify clearly these total portions, that I am separating this thing through orange color. This region is called the positive points, positive points from D train and D cross validation. This is the positive regions from D train and D cross validations. And this thing, just I am using another color. I think here it will better. This region, that green color is the negative points, and it's the D train plus D cross validation. These 2 points, these 2 regions we have got. Now just see this thing. Now what is the actual motto, why we have drawing this thing, why? So we have seen our the train data, cross validation data, test data are the same kind of data. So for each partitions of data, our data same kind of data we have, xi and y corresponding its output, corresponding its this output is called the class label. This output is the called the class label. It will be 0 or 1. We have seen for each partitions of the, it is the same kind of data sets. Now the thing is the why this happening, why this thing. Actually we have doing this partitioning job randomly. So if we do the job randomly, then for well distribution data sets, we will see this kind of jobs. So let's write the thing one by one. I think then it will be clear. So first we have seen that our D train, first we have seen our that D train data and D cross validation data, D train and D cross validation data, and as well our D test data. If we just consider the whole data sets, then its data sets do not overlap perfectly. Okay, means if we just consider the whole data sets, D train as well as D cross validations and D traced, then we will see these things are not, these negative regions and positive regions, it not overlap for each partitions perfectly, for each data partitions do not overlap perfectly when the condition is when it is randomly sampled, when it is randomly sampled. This is the main thing. If this is randomly sampled, then it is do not overlap perfectly. These two things are main. Now let's see the second thing. Let's see. So the second thing is that we have seen if there are many positive points from D train data. Suppose see this region. Suppose this. Let's see these regions. In this region, suppose let's write down first. Then we'll see. if there are many positive points from our training data set, suppose in a region, then it is high likely highly likely high likely high likely to find the many positive point positive points from cross validations also. Just we will see this thing through a picture. Just write down thing in the same region. Okay, so this thing all work positive as well as for negative also, not only for positive. These things we work for negative as well as for negative, positive as well as for negative. So let's see this thing pictorially. Suppose let's take we have a positive points here. Suppose we have choose some regions. Suppose let's choose, I am some choosing some regions. Here we have taken some positive points from our trained data sets, and some negative points, also we have trained data sets. Then there may be chance that in the same regions there may be the same chance that the positive data also like from our cross validation data set. Okay, the same chance, if we just find the probability that positive point on the particular regions, the positive point from the training data set, possibilities of find the probability of the positive data points from the training data sets, then the same probability will be happen from if we just find the probability from the data point, positive data points from the cross validation data point. Okay, so the same is, so the if you just take this region as density, okay, just if you just take this regions as density, the density of density of positive points from the train data, suppose density is high. Okay, we have got this thing. Suppose density from the positive points from this region, only for this region, from the train data set is high, then the same things also for correct true for cross validation data. The same thing is true for cross validation data. So the positive points, and for the cross validations also it is true. So the same density will be happens, or in the I will just call this density as probability, means probability of, and just if you just write this thing in probability concept, so probability of the trade equals to positive, this thing is approximately equal to the cross validations positive for a particular region. Okay, I think the thing is clear. The same things also happen for negative. So there also may have occur one or two outlier, that's not matter, but I'm just taken the chances concept, just probability concept, this thing the same probability also occur. So third definitions is like, third definitions is if there are very few. Suppose you have taken here if their density is high, then the same things also true for cross validation data also. Suppose if our density is low, then what happen? If there are very few points, positive or negative, both the same, both for both the same it is true. In a region or the train set, then it is the same. Then it is very unlikely if there are few points from a particular region from train data sets, then the same things, the very unlikely from positives or the negative points from the cross validations also in that region, the particular same region. Okay, so let's see this thing in practically let's see this thing. Suppose let's choose our regions is like that. Suppose let's choose UAP regions, and they have a very few points positive for train data sets. Suppose let's take I have taken here negative points. Suppose let's take we have a very few, suppose two points only on this region from our negative points only these regions, and they are have the same chance, they are have the same chance that the few points is also live from here cross validation data set. There are few chance if they are in that particular regions, if they are have a few, suppose let's take a few points from our few negative points from from our detraining data sets, and oppositely if you suppose very large data set, very positive set of data points, and they are maybe in just in two, just definitions, see the definitions. So in the particular region there may be a chance that positive data points also lie on this cross validation data set. The same thing may occur here, if the chance that the few points from our training data, the same chance also true for our cross validations also, cross validations. So just write this thing here, just write this thing here, just I am using the red color. So for this negative point, it is very low density. So it is very low density. So the same things also true for this point. So may not find. It may occur here or may not find. May not find here. It may not be find. May not be find any point from the cross validation. Okay. I think cross validation for I am taking here as a red color means negative plus. Density negative point from D train, then we not find any point the form cross validations for negative points, negative. Okay, I think the three definitions is clear, the both are the same thing. If first one is that if our training data, cross validations data and test data do not overlap perfectly, if we just doing the sample randomly, just partition the our whole data set randomly, that 3%, then there may not overlap perfectly. Okay, and the first thing is if for a particular reasons, if the for a particular class point, for a particular class point, if its chance is high, the same chances also is true for a cross validation data set. If the chance is low for a particular regions and for particular class level for training data sets, and the same things also happen for the same class level data point for the cross validation data also. Okay, this is the main three things for visualize visualize a perfect data sets. If our data sets is totally imbalanced, then we cannot see this kind of distribution, this kind of plot. If data is imbalanced, then or if in a data sets is noisy is occurs, then we cannot find this kind of situations. You can see this, actually this, what is this? Actually this is a noisy point. Actually this is a noisy point. This one is also a noisy point. This one is also noisy point. So this thing also happen for a well distributed data, for a balanced data, for perfect data. Okay, but this kind of situations we have not seen for a imbalanced data, for a noisy data. This kind of situations we cannot see. Okay, I think the main motto visualizations and its concept is clear all of you. Okay.